Hey, I hope everybody's doing well. In this video, I want to talk about the coordinates of a vector, specifically with respect to a basis. So consider P3, the set of polynomials of degree less than or equal to 3. I'm going to look at this following basis here, and I already know this is a basis from some previous work that I did. So I have four vectors here. And what I want to do is I want to figure out the vector associated with these coordinates. Well, the way to do this is an ordered basis. I'm going to kind of emphasize this word ordered. I have a first, second, third, and fourth vector, and I have these coordinates. These are coefficients. 1 is going to be the coefficient for the 1. The 3, I'm going to multiply that by x plus 1. Now this second vector, I'm going to multiply by -4. And the third vector, I'm going to multiply by 2. And they're going to collect like terms. And that's going to be my associated vector with those coordinates. So I'm going to leave that to you to make a decision on how to add polynomials together. The harder question here. What are the coordinates of this particular vector? So what are the weights that I need to multiply on these vectors to get this one right here? Well, one thing I can do is I can transfer this all to a Mathematica file. So in this particular case, I'm going to write these as rows and then take a transpose, so it's a little easier for me to write down. So what I do know is I have cubic polynomials here, well, degree 3 or less. So I'm going to create my matrix, and I'm going to write this in row form. So I'm going to have 1, 0, 0, 0. 1 is my constant, the x term, the x squared, and finally the x cubed. Then the next one will look like a 1, a 0, and a 0. Because that's just x plus 1. Now the next one looking like -2, 1, 1, and finally 0. The last one, let's see, -1, 2, 0, and then a 1. Now the idea here is I want to figure out the coordinates of this vector over here. So how do I actually put this in here? Well, one thing I can do is I'm going to just tack this on the end here. 1, 1, 1, 0. And then I want to take a transpose of this whole thing. So let's just see what this looks like. I will do an A matrix form for us here, and I wind up getting this particular matrix here. This represents the constant 1, 1 plus 1x. This is the second polynomial, and I'm basically having an augmented matrix here. So how do I get solutions when I have an augmented matrix? Well, probably the easiest thing to do is row reduce. That's like my favorite thing to do when we're trying to do lots of computations here. So let's see, I am going to hide that one, and I wind up getting this. That's a little bit hard to read. So again, let's try this matrix form, and I wind up getting this. So let's see. Well, how do I read this? This says the coefficient for my first polynomial is 3. The coefficient for my second polynomial is 0. Coefficient for my third polynomial is 1. So if I go back over here, what I'm going to have is I'm going to multiply this by 3. I'm going to multiply this one by 0. I'm going to multiply this one by 1. And then the last one, well, I'm going to multiply it by 0. And if I do that, 3 plus x squared plus x minus 2, lo and behold, I wind up getting this. I hope this was helpful. If you have any questions, let me know. Bye.